Thousands of liters of oil flow aren't needed to control this compact harvesting head, yet it handles logs with surprising efficiency. The Narva S23 harvester and firewood processor proves that simplicity can deliver power. Operators don't need to juggle multiple controls, making the work surprisingly smooth. The first task positions the head to lock vertically for delimbing. When a tree is cut, its own weight tilts the head, letting the delimbing stroke handle forward and backward movement automatically. Grapple open/close valves control delimbing, while sequence valves manage grippers and blades in perfect timing. Next, the cutting blade engages when the delimbing stroke reaches maximum and pressure limits. The entire system runs on only 40 liters per minute of oil, keeping it economical and lightweight. Installation is quick, with no extra hydraulics or electricity required. The mechanical tilt simplifies complex cuts, and grapple operations are intuitive, letting operators complete cycles efficiently. Overall, the S23 combines clever mechanical design with practical hydraulics, processing trees with minimal intervention. Its simplicity doesn't compromise capability, offering a compact solution for tractors and small excavators. Even newcomers find the head straightforward to operate. Processing over 1,000 veneers daily, the factory achieves unmatched precision. Logs are delivered to the facility, stacked neatly for processing. Large saws slice the wood into manageable sections, preparing them for peeling. Hard to believe how quickly these logs are turned into long, thin veneers. The peeling machine then converts each section into delicate sheets, revealing the birch grain and setting the foundation for high-quality plywood. Controlled drying ovens carefully reduce moisture in each veneer, ensuring durability and preventing warping. Even the smallest imperfections are noticed and corrected early in the line. Once dried, veneers are composed and layered to achieve consistent appearance and structural integrity. Shorter pieces are joined using scarfing, forming longer sheets without compromising strength. It's surprising how seamless these connections appear after pressing. Each veneer seems to fit perfectly, almost like pieces of a puzzle. Layup is where human oversight and automation work in tandem. Layers are arranged according to design, balancing aesthetics and durability. The arrangement almost feels like stacking building blocks with purpose. Pressing then compresses the veneers under heat and pressure, bonding them into uniform panels. Panels stay incredibly flat, even across large surfaces. This stage ensures the plywood stays flat and robust, no matter the size. After pressing, panels are trimmed to precise dimensions. Overlaying applies surface veneers or films, adding texture and protection. The overlaying process makes each board feel extra durable. Patch repairs and overlaying together make each board reliable and consistent. A final inspection filters out any panels that do not meet strict quality standards. Even minor misalignments are caught and corrected before shipment. Throughout the facility, automated systems and skilled staff create an efficient, synchronized workflow. Machines move with a rhythm that almost feels alive. The way these machines and operators coordinate might remind you of a giant clockwork mechanism. Unexpected movements show that human attention still makes a difference, even in a highly automated environment. It's fascinating how much effort goes into perfecting every panel. Finally, high-quality birch plywood emerges, ready for use in construction, furniture, and decorative applications. Every board carries the mark of a highly refined process. The strength and consistency of each panel are remarkable. The veneers themselves reveal subtle beauty beneath the surface. What keeps each logo aligned despite rapid conveyor movement? The RoboPel 250 moves with automated precision, spreading glue evenly and guiding the veneer for perfect placement. Hard to imagine each logo is applied flawlessly at such speed. Once pressed, panels continue descending, ensuring smooth surfaces. The system integrates glue spreading, pressing, and veneer handling seamlessly. Occasionally, a board shifts unexpectedly, producing a tiny wobble in the line. This machine makes branding look effortless, yet highly controlled. The newest veneer core joint machine lines up sheets precisely, ready for gluing and pressing. Unexpected how clean the joints come out. Rollers guide each veneer while glue is applied evenly. Who knew plywood could be this consistent? Sheets are pressed, trimmed, and stacked efficiently. Automation meets finesse here. The scrap bin 385 lines up against the towering tree. It's ported top end primed for heavy cutting. Didn't think a single saw could tackle such a giant trunk so smoothly. Blade teeth bite into the thick wood, progressing steadily as the machine hums through each section. Branches are clear, and the operator guides it precisely along the tree. Watching this level of control on such a big tree is impressive. Adjustments enhance efficiency before the final slice. Even a homemade experiment like this handles large timber with ease. Logs up to 1,700 millimeters in diameter are cut with ease. A log is guided along the rails of the WM1000, each one positioned to match the machine's hydraulic adjustments. The design allows for precise control over even irregularly shaped logs. Surprising how stable even the heaviest logs remain. The blade wheels spin steadily, cutting through diameters up to 1,150 to 1,700 millimeters with precision. Operators control the minimum and maximum cut heights, using the 1,070 millimeters crown steel blade to handle up to 6,000 kilograms of timber. Every adjustment is calculated to reduce wear on the blade while maximizing cut quality. Never thought a log this big could be managed so smoothly. Rail extensions allow longer logs to fit securely for full-length cuts. The power feed advances each log with consistent force, while the head drive lifts or lowers the blade to match thickness requirements. Hydraulic sensors automatically compensate for slight log movements. Unexpected how uniform every slice comes out, even with variable log shapes. Minimum cut widths of 200 millimeters and maximum of 1,700 millimeters are adjusted dynamically. Throat capacity ensures rollers maintain proper contact, keeping the log steady as the cut progresses. This kind of control would impress anyone familiar with manual sawing. Fine-tuning the feed rate prevents splintering even on dense hardwoods. Cutting continues efficiently with multiple passes, and hydraulic motors assist blade guides, keeping alignment accurate. The system adapts in real time to variations in log moisture content. Logs exceeding standard lengths are accommodated without compromising stability. One could almost forget how much raw material is involved here. The machine maintains constant pressure and feed, combining electric motors from 22 kilowatts to 37 kilowatts to optimize performance. Blade tension is monitored continuously to avoid inconsistencies. Rail height above the blade ensures the proper angle for each cut, while extension options allow adjustments for unusual timber sizes. Even a challenging log doesn't slow this system down. Energy efficiency is built into the hydraulic system, reducing operational costs. Final cuts are checked against width and height parameters, guaranteeing uniformity. Logs are then removed and stacked systematically, ready for further processing. Impressive how the machine keeps everything so orderly. Occasional bark pieces flick off during cutting, adding minor unpredictability and a hint of humor to the process. Some logs just refuse to sit quietly, making the cut more interesting. Every component, from the head drive to the power feed, works in harmony with hydraulic precision to maintain consistent quality. The WM1000's new hydraulic system enhances the machine's reliability and ensures safe, accurate handling of heavy, oversized logs. Feel the raw power of the Center 1000H as it slices through giant logs with precision. It's surprising how smoothly even the tallest trees are handled. Hydraulic adjustments align each log perfectly for the first cut, ensuring consistent results across varying diameters. The cutting blade moves with power, slicing through timber sections with ease. Never thought a saw could manage such weight so steadily. Once the initial cut is made, logs are rotated and repositioned for secondary slicing. Operators maintain a steady rhythm to match the machine's efficiency. Thickness adjustments are dialed in using the hydraulic system, allowing each cut to meet strict dimensional requirements. The Center 1000H handles logs up to 1,000 millimeters diameter, cutting sections precisely without wobble. Unexpected how uniform each piece emerges, considering the size of the logs. Following slicing, logs move along guides toward trimming stations. Blade calibration is critical to maintain straight edges, and this machine keeps it accurate. Trimming removes excess and prepares sections for further processing, while power feed motors maintain a steady pace. Logs of different diameters are accommodated without slowing production. Even complex timber shapes are aligned efficiently for clean cuts. Final pieces pass through quality checks, confirming thickness and width tolerances. Seeing such a coordinated system makes the workflow feel almost effortless. Any minor deviations are corrected immediately. Hydraulic systems power blade guides and feed mechanisms, maintaining consistency throughout the process. Safety barriers and controls are integrated to handle oversized sections securely. It's fascinating how technology and human oversight blend seamlessly here. Once complete, processed timber is stacked for transport or further finishing. This machine really sets a standard for heavy-duty forest processing. Occasional bark chunks flick off, adding small surprises that keep operators alert. Even stubborn logs seem to respect the blade's authority. Follow the boards as they move from raw timber to precisely glued beams. The journey of raw timber begins with cleaning and stacking, the first step in preparing each board for precise processing. Each board is thoroughly inspected, with defects such as knots, cracks, or discolorations marked carefully. Early detection of flaws prevents hours of rework later. Highlighting flaws early prevents problems down the line. Once marked, boards are temporarily stored in a Zwischenablage, an intermediate storage area that keeps the production line flowing smoothly. Even a short delay here can ripple downstream if not managed. Unexpected how even short pauses are critical for workflow management. This stage ensures that boards needing urgent attention are prioritized without slowing down the overall process. Flawed sections are then removed in the Auskappen der Holzfehler step. Knots and cracks are cut away, leaving only usable wood. It's fascinating how uniformity begins with careful removal of irregularities. Never thought defect removal could be so systematic. Workers monitor each board closely to guarantee only quality material moves forward. After defect removal, boards enter Lehm-Zinkenfrozen, where precise finger joints are milled along the edges. These joints prepare the wood for gluing, ensuring strong connections. Even small misalignments here would be costly later. The uniformity of these joints is fascinating, even with wood of varying density. Glue is applied to each joint at Zinkenvellum and pressing, and boards are pressed together. The result is long, stable beams, ready for further processing. Seamless joints like these are the backbone of structural integrity. Once pressed, boards are stacked automatically, maintaining alignment and preparing for the next stage. The stack moves to the Lem press, a new press installed in 2023, designed for multiple boards at once. Boards are loaded, the press closes, and uniform pressure is applied across all surfaces. The synchronized movement of boards into the press is surprisingly graceful. The force here is impressive. Even thick beams remain perfectly flat. After pressing, beams are removed to reveal perfectly bonded joints. Seeing long beams emerge straight and uniform is oddly satisfying. Even thick beams that seem difficult initially are handled flawlessly. The next stage is Norrhobeln, where beams are roughly planed to remove irregularities. Rough planing ensures smoother finishing later. Planing speed is balanced carefully to avoid overcutting. Glue is reapplied when needed, and boards are loaded into the main press, Presse befüllen, and pressed, Schließende Presse, to finalize bonding. Once curing is complete, the press is emptied, Presse entleeren, and beams are ready for precise planing. Even small adjustments at this stage can significantly affect final quality. Operators watch closely, ready to tweak feeds if boards misalign slightly. During precise planing, beams are guided through an automated feeding system, Automatische Zufuhr, which maintains spacing and orientation. You can tell the engineers thought through every detail here. Boards then pass through the four-sided Hobeln und Phasen station, which planes all four sides and applies chamfers. Minor surface flaws are removed, and a consistent profile is achieved. Chamfering edges helps prevent damage during transport. Simple yet effective. Once finished, beams are automatically stacked again, ensuring efficiency and order. The reliability of this automated stacking is fascinating. Seeing hundreds of beams stacked perfectly without human intervention is impressive. Following planing, beams move toward packaging and storage, Verpackung and Lagerung. Boards are carefully stacked, bundled, and stored for shipment or further processing. Unexpectedly, even with heavy beams, the system maintains precise alignment. Sometimes, boards wiggle as they settle, a small moment that keeps operators entertained. Minor bark fragments sometimes flick off during handling, adding moments of humor and surprise to the workflow. Some boards just refuse to cooperate, making operators chuckle. Every step, from defect marking to pressing and planing, contributes to structurally sound, high-quality beams. The line shows how planing plus automation achieves consistent excellence. The workflow balances automation with human oversight. Automated systems like presses and planers handle volume and maintain uniformity, while workers monitor quality and intervene when needed. Each stage, cleaning, defect marking, flaw removal, finger joint milling, gluing, pressing, rough and fine planing, chamfering, automatic stacking, and final packaging is executed in strict sequence. The thoughtfulness behind this sequence is impressive. Boards are inspected continuously, and the integration of new presses ensures consistent pressure across all beams. Automated feeding and stacking systems minimize manual handling while maintaining stability. Even boards of varying length and thickness slide perfectly through the line. Finger joints and pressing create strong, long-lasting connections, while planing and chamfering refine the surface, preparing beams for structural use. Seeing such uniformity across hundreds of beams is astonishing. The coordination here is a lesson in industrial workflow design. The final product is a series of laminated, precise beams ready for construction or furniture. Automation allows for efficient handling of large volumes, while quality checks ensure each beam meets strict specifications. The coordination between humans and machines is fascinating. Each component of the production line, from the initial cleaning stage to the final packaging, contributes to a seamless process. From start to finish, the production line highlights careful planning, modern engineering, and quality control. Temporary storage, zwischenblage, flaw removal, finger joint milling, pressing, planing, chamfering, and automated stacking all form a coherent workflow. Watching the line move hundreds of boards with such precision is impressive. The system adapts dynamically, compensating for variations in size or shape, resulting in structurally reliable and aesthetically consistent beams. Efficiency and quality rarely go hand in hand so seamlessly. Throughout the line, human operators and machines work in harmony. Inspection, defect removal, milling, pressing, planing, and stacking are all coordinated with precision. Unexpectedly, even a single board can reveal challenges that the system corrects seamlessly. Automation reduces labor-intensive tasks while maintaining exact tolerances, making the facility both efficient and safe. Wild how smoothly a single board travels through over a dozen steps without error. The integration of high-capacity presses, advanced planers, and automated feeding ensures beams meet demanding standards. Chamfered edges prevent damage during transport and handling. Automated stacking reduces clutter and organizes boards for downstream processes. Some boards seem to have a mind of their own, slipping slightly before settling. Funny to watch. Each stage builds upon the last, emphasizing quality, efficiency, and safety. Seeing raw boards transform into precise structural beams through this workflow is fascinating. Even minor variations in wood density are handled without visible error. By the time beams reach the packaging and storage phase, they are fully prepared for shipment. The entire line demonstrates the balance of technology and human oversight. Automated presses and planers enhance both speed and consistency, while workers ensure quality control at every step. The system's ability to handle large, heavy beams without compromise is impressive. Each component, from inspection to final packaging, is integrated into a carefully designed workflow. This is why modern timber processing can produce high-quality beams reliably and efficiently. The line reflects decades of practical experience applied to modern automation. Hundreds of panels, dozens of beams, and just 2 days to assemble the framework. The project starts with manufacturing the interior partition walls. Each component cut, labeled, and prepared precisely for installation. Even minor differences in the panels could affect the whole fit. Engineers accounted for that. The precision in marking each panel saves countless hours on site. Once prepared, the walls are lifted into place on day one, forming the framework of the house. Cranes and crews coordinate to position each panel exactly where it belongs. The speed and coordination of this stage is fascinating. Every panel locks into place without struggle. Unexpected movements sometimes require split-second adjustments, showing the crew's expertise. Unexpectedly, some panels lean slightly during lifting, prompting quick adjustments and laughter among the crew. It's impressive how minor corrections are handled instantly. Temporary bracing is cleverly applied to prevent any wobble during assembly. After the walls are secured, the assembly moves to the roof. Day 2 focuses on raising the roof structure with Brettstapel elements, stacking prefabricated beams to form the frame. Each beam aligns with precision, ensuring structural stability. Seeing the roof rise piece by piece shows how planning and teamwork merge perfectly. Temporary supports keep everything in position until the final joints are fastened. The use of pre-stacked elements significantly reduces installation errors. A slight misalignment could cascade if not checked immediately. Measuring devices are used to confirm angles before each connection is tightened. The crew continuously checks alignment and measures dimensions during assembly. This constant monitoring guarantees that every component fits perfectly with adjacent elements. You can tell the engineers' foresight in panel sizing and connection details is paying off. The workflow balances speed with accuracy, preventing mistakes from accumulating. The combination of craftsmanship, mechanical lifting, and on-site adjustments demonstrates the efficiency of modular construction. Once the roof framework is in place, the structure stands as a cohesive wooden house, showcasing the integrity of prefabricated elements. Seeing raw panels and beams converge into a complete framework is unexpectedly satisfying. The workflow highlights efficiency. Initial wall fabrication, raising walls, and roof assembly are conducted in strict sequence, minimizing errors and maximizing safety. Coordination between humans and machinery ensures that the house progresses steadily, even under challenging conditions. The modular design allows for future flexibility in interior layouts. Throughout the assembly, minor imperfections are corrected immediately, temporary supports guarantee stability, and teamwork maintains momentum. The interplay of precision engineering and hands-on adjustments makes modern timber construction fascinating. By the end of day 2, the structural shell of the house stands completed, ready for finishing work. Even with complex shapes, modular design keeps the process smooth and manageable. Seeing the house fully framed makes the planning and engineering effort tangible. Watch as the panels turn into a staircase under skilled hands. The construction of CLT stairs kicks off with precise cutting of panels, each dimension carefully checked. Panels are then assembled into stair elements, aligning edges to ensure strength and stability. Crazy how these large panels fit so snugly with minimal adjustment. Fastening and gluing secure the structure, while workers monitor alignment constantly. You can tell attention to detail here prevents wobble later. Once complete, the stairs are lifted into place for final fitting. The final result is a solid, aesthetically clean staircase, combining engineered wood strength with careful assembly. Imagine walking through the construction of a timber-framed house with garage, each panel designed to fit perfectly. The prefabricated wall and ceiling elements are planned and cut using CAD software, ensuring dimensions match precisely. Every beam is calculated for fit before it even leaves the workshop. The panels arrive on site and are lifted into place, forming the skeletal framework. The crew installs walls, ceiling panels, and roof trusses in sequence, carefully aligning each component to maintain structural integrity. Connections between walls are secured, and alignment is double-checked for stability. Roof trusses are then positioned, following the same thorough planning. The precision in handling timber ensures minimal adjustments are needed. Finally, all elements come together, creating a strong, accurate timber frame ready for finishing. The combination of prefabrication, CAD planning, and skilled assembly ensures the house stands perfectly aligned. Wendway.